For our entire history, we've looked to the stars and contemplated the true size of the universe. With each new generation of technology, the cosmos has revealed itself to be vastly more complex than we had ever conceived. We built maps, measured the expansion, and believed we were grasping the scale of it all. We even gave the observable universe a size, a staggering 93 billion light-years across. As it turns out, our perspective was profoundly incomplete. The James Webb Space Telescope has begun to send back its first major datasets, unveiling a new vista of the universe. Its images reveal something so ancient, so populated, and so advanced in its infancy that our models had ever predicted, that they are forcing scientists to rethink the fundamental theories of cosmic evolution. What you're about to see will recontextualize our place in the universe. To comprehend the monumental nature of this new perspective, we must first recall what came before. For decades, our deepest view of the cosmos was defined by the Hubble Space Telescope. It was a marvel. Hubble gave us the iconic ultra-deep field image, a landmark achievement captured by observing a seemingly empty patch of sky for over 11 days. It revealed a celestial zoo of galaxies, allowing us to estimate the number in the observable universe grew to a staggering 2 trillion. Each point of light was not a star, but an entire galaxy containing billions of its own stars. Hubble taught us that looking deep into space is looking back in time. The light from the most distant galaxies it could see had traveled for over 13 billion years. We were seeing them as they were when the universe was just a toddler, a mere 500 to 800 million years old. Based on these observations, we constructed our standard model of cosmology. It was a robust story that predicted the first galaxies should be small, simple seeds gradually growing over billions of years into the grand structures, like our own Milky Way that we see today. The model worked, explaining almost everything we could see. But for all its power, Hubble has inherent limitations. The light from the most ancient galaxies has traveled for so long through an ever-expanding universe that its wavelength has been stretched deep into the infrared spectrum. This is precisely the light that James Webb Space Telescope, with its giant golden mirror, was designed to detect. It's not just a larger telescope. It can see through the cosmic dust that obscured Hubble's view and capture this ancient reddened light. Webb's primary mission was to witness the cosmic dawn, the very first flickers of light from the first stars and galaxies, and to find those small, simple baby galaxies our models predicted. But that's not what it found. Almost immediately, Webb started delivering results that challenged our theories. It pointed its golden eye at the darkest corners of the sky and found a stunning population of bright, early galaxies that demand a new explanation. Not only were there far more galaxies than expected, but they were massive, luminous, and remarkably complex. Scientists were stunned. Instead of wispy clouds, Webb found galaxies that had somehow skipped billions of years of evolution. Take the newly designated galaxy MOMZ14. Webb is seeing it as it was just 280 million years after the Big Bang, and it's already a luminous, significant object containing heavy elements, like finding a fully grown adult in a nursery of newborns. In another instance, scientists found a primordial galaxy resembling cosmic grapes, a structured disk made of dense, clumpy regions of furious star formation. The implication is staggering. The process of building galaxies wasn't a slow, gentle accumulation. It must have been a far richer and more dramatic process than we ever knew. The opening chapters of the cosmic story are being rewritten. But if individual galaxies could get so big, so fast, what does that say about the vast structures they belong to? This is what it feels like to have the scale of your world change. It's the realization that the universe isn't just vast, but teeming with structure and history. To see this new reality, we have to zoom out from the scale of galaxies to the true scale of the universe itself. For years, cosmologists have theorized that galaxies are not scattered randomly, but are organized into a colossal structure, the cosmic web. In this model, the universe is a network of unimaginably long filaments of dark matter and gas, and galaxies are born within them. Where the filaments intersect, They form massive galaxy clusters, the great cities of the cosmos. Hubble could see the bright clusters, but the filaments themselves, the vast cosmic highways connecting everything, were largely invisible. Until now. Using Webb, astronomers are conducting the largest observing program of its first year, called Cosmos Webb. It is meticulously scanning a patch of sky about 3 times the area of our full moon, stitching together thousands of exposures into one seamless image. The result is the largest and deepest view of the universe ever captured, a publicly released map containing a catalog of nearly 800,000 galaxies. Where Hubble gave us a glimpse of a busy city block, JWST has provided the entire metropolitan area with its sprawling suburbs and the highways connecting them. For the first time, we are directly seeing the earliest strands of this cosmic web, detecting a thread-like arrangement of 10 galaxies stretching 3 million light-years long, just 830 million years after the Big Bang. The true scale of the universe isn't just a number, it is the scale of this structure. Webb is showing us the ghostly architecture of the cosmos, but in doing so, it has deepened another, more fundamental mystery. There is a crisis in cosmology, often called the Hubble tension. We have 2 primary ways of measuring how fast the universe is expanding, and they give 2 different answers. The first method looks at the afterglow of the Big Bang and uses our standard model of cosmology to predict the expansion rate today. It gives a value of about 67 kilometers per second per megaparsec. The second method measures the expansion rate directly by observing stars in the local modern universe. This gives a faster value, around 73. For years, scientists thought the discrepancy was likely an error in measurement. The James Webb Telescope, with its incredible precision, was meant to be the final judge. Well, the results are in, and they have only intensified the debate. One major team, led by Nobel laureate Adam Rees, used Webb to make the most precise measurements of the local universe ever taken. Their result confirms their previous findings with Hubble. The universe nearby is expanding faster than our models predict. They argued the tension is real, and the problem is not in the measurements, but in our understanding of the universe itself. However, another team, led by Wendy Friedman, used Webb's data to observe different types of stars and came to a different conclusion. Their results suggest a slower expansion rate, closer to the value predicted by the early universe, which may mean there is no tension at all. Think about what this means. The most powerful telescope ever built is giving us 2 revolutionary yet contradictory pieces of evidence for the biggest question in cosmology. Either our standard model of the cosmos is incomplete, requiring new physics, new particles, or a new understanding of dark energy, or our methods for measurement are flawed in a deep, unrecognized way. Either way, we're on the precipice of a revolution. So where does this leave us? The James Webb Telescope was built to show us our origins. Instead, it has shown us that our perspective was profoundly incomplete. We thought galaxies grew slowly. Webb is revealing giants in the cosmic dawn. We thought the universe was a random spray of galaxies. Webb is revealing the intricate strands of the cosmic web that bind it all together. And we thought we understood how the universe expands. Webb has returned evidence that has thrown the scientific community into a thrilling state of confusion. The true scale of the universe, as revealed by Webb, isn't just about size. It's about a cosmos more complex, more structured, and more mysterious than we ever dared to imagine. Our old maps are now being redrawn. Our trusted theories are being questioned. This is not an ending. This is the very beginning. We are the first generation to witness this new reality, standing on the shore of a cosmic ocean whose depths we are only just beginning to chart. And perhaps the most awe-inspiring thought of all is that even this incredible map, the largest ever made, is just one tiny window